The elimination method. Before I talk about the elimination method in this example, let's talk about it more generally. Where does it come from? Well, most of the time, math, believe it or not, reduces to common sense. Would everybody agree that 5 equals 5?
Yes.
Unless you're particularly argumentative today or you're crazy, 5 equals 5, right? What about 2 equals 2? Is that true? Is this kind of a set of 2 equations, 2 unknowns? Kind of lame representation, right? But yeah, 2 equals 2 is an equation, 5 equals 5 is an equation technically. What happens if you add both sides of both equations together vertically? Do you still get a true equation?
Yeah.
You get 7 equals 7, don't you? Well, the fact that you can add equations together and still have a true equation is what's behind the elimination method. So it's really just kind of common sense, and it seems so basic that you might not even think of it. Okay, so with that in mind, let's go to the example I have here. Solve using the elimination method. X minus y equals 7 and x plus y equals 3. You guys, I don't have to go back to basics. You can probably figure out what would be the easiest way to solve this equation using elimination. What are you going to do?
Just add the 2 equations.
Just add the 2 equations, because what did you notice? Right away you noticed in the top equation you have a minus y. In the bottom equation, you have a plus y. When you add them together, the y's are going to knock each other out, right? If you add y to negative y, you make 0. 0y. So that's the idea behind elimination. We're eliminating the y variable. In this case, do you have to eliminate y? It'd be best in this case, but not always, right? Sometimes it's easier to eliminate x. So let's add these together. I'm not even going to rewrite them. I'm just going to add them together. And what do you get? Remember, it's 1x. Here, 1x here, add vertically, like terms, what do you get? So you get 2x gone is equal to 10. Negative y plus y makes 0. We've eliminated y. We get the simple equation, 2x equals 10. So what does x equal? Divide both sides by 2. X equals 5. Notice I didn't show my work on this one. I go back and forth between showing my work because I really want you to get in the habit of not showing your work. Just go, well, okay, no, what do I mean by that? Not showing the scratch work is what I mean. Not showing the division by 2 on both sides. Just going down to the next step, what you'd get after you divide both sides by 2. That's your ultimate goal, but a lot of people are comfortable showing their work, and I don't want to make you uncomfortable. So when you become comfortable just going from 2x equals 10 to x equals 5 without showing anything, go for it. If you're more comfortable showing division by 2 on both sides, show that. Okay, but just to make you a little more comfortable with it, I won't always show you the work. So you guys are okay with that? So we're done. X equals 5, done, right? No, what do we need? X, yeah, we need y. We need y. We have x. How do we get y? We know x equals 5, so we could substitute 5 in for x in which equation? Does it matter? Does not matter. So let's do the second equation just because everything's plus. So we plug x into the second equation. What do we get? 5 plus y equals 3, or y equals, let's show the work on this one. Y equals, subtract 5 from both sides, negative 2. There we go. How do we write the answer? Ordered pair, 5, negative 2. What does that represent? Yeah, the intersection point of the 2 lines. If you were to graph those 2 equations, it'd be the intersection point of the resulting lines in the graph. Okay. So is elimination always that easy? No, in your dreams, right? It's not always that easy. So in the next example, same directions, elimination method. We have a system of 2 equations, 2 unknowns. 3x minus 4y equals 16, and 5x plus 6y equals 14. So we want to eliminate a variable. We eliminated, in the last example, which did we eliminate? We eliminated y. For the sake of argument, let's eliminate x. Notice I have a 3x in the top equation, 5x in the bottom equation. It's kind of like finding common denominators, isn't it? Actually, it's exactly like that, except we need not the same values, but opposite values, right? So think to yourself, what's the smallest value that both 3, the coefficient of x in the first equation, and 5, the coefficient of x in the second equation, what's the smallest value that they both go into evenly? 15. Okay. So what could I multiply the top equation by to say get positive 15? Positive 5. Now you have to multiply everything in the top equation, including on the right-hand side, that's 16 by 5. So what do you get if you multiply everything by 5 in the top equation? Well, by design, 15x, is it plus 20y? Minus 20y equals 5 times 16. I think it's 80, isn't it? Yeah. And then now remember what we're trying to do. We're trying to get two equations such that when we add them together, they knock out the x values. So instead of having in the second equation, instead of having a positive 15x in the x position, we want a negative 15x. So what could I multiply this 5x by to get it to be negative 15x? Negative 3, and then you got to multiply everything in the whole equation through by negative 3. What does that give you? Negative 15x minus 18y equals, what's negative 3 times 14? Negative 42. And now do you see we're ready to add? Add them up. So by design, 15x plus negative 15x makes 0. Okay, negative 20y minus 18y, or plus a negative 18y if you like. What does that make? Negative 38y. And then 80 plus a negative 42, or 80 minus 42? 38. Isn't that nice? So how do we get y? Divide both sides by negative 38. So what does y equal? Y equals negative 1. But as you know, we're not done. You guys tell me, how do I get the corresponding x value? What's a way to do it? Yeah. Which equation? Does it matter? I don't think it really matters. It's not going to be much harder either way. I'll plug it in the first one up here. Oh, I'm sorry. I pointed at the wrong thing. Let me try that again. I'm going to plug it in right up here in the y. And so that gives me 3x minus 4 times what, a negative 1 equals 16. So what is that? 3x plus 4 equals 16. What does 3x equal?
12.
12. Subtract 4 from both sides. Or x equals 4. So how are you going to write the answer? 4, negative 1. Could you check the answer if you wanted to? Yeah, plug in x equals 4 and y equals negative 1 into both equations. You better get a true statement both times, right?